This is a video on chemical equations based on a worksheet I made and gave out in class. So there's a series of questions I'll give you on the worksheet as follows. Looks something like this. Okay, so I'll ask you to state the type of reaction being shown. Now, the way to do this is to break them down. You've got KOH, K is potassium. OH, whenever you see OH, that's hydroxide. That's a polyatomic ion. Okay, H, hydro for hydrogen, oxide for oxygen. H2SO4 by definition is sulfuric acid. So you have a hydroxide, an acid. That's an acid-base reaction. Okay, hydroxides are bases. Number two, we're given CaCO3 plus HCl. Ca is calcium. CO3, this is carbonate. That's the carbonate polyatomic ion that's latched onto a calcium atom. HCl, that's hydrochloric acid. So you have an acid and carbonate reaction. Let's do the next couple of questions. Okay, same idea. So NaOH, that's sodium here, and that's hydroxide, so that's sodium hydroxide. I'll just put hydroxide for now. HNO3 by definition is nitric acid. So you have an acid plus a base reaction, because hydroxide's a base. Zn is zinc. HCl is hydrochloric acid. Zn, zinc is a metal. So you have a metal acid reaction. The last one, you've got sulfuric acid. And you've got rubidium here, Rb. CO3 is carbonate. So you have acid plus carbonate. Okay, it's just knowing your polyatomic ions using the periodic table and knowing the names of common acids. So that was question one. Question two involved balancing the following reactions, and here they are. Okay, this is a textbook example, a common example of a acid-base reaction. Okay, hydrochloric acid here, that's an acid. Sodium hydroxide, that's a base, and that forms sodium chloride, which is a salt, and water H2O. Let's balance it. So step one is to make a list of the elements from left to right. You've got H on the left, starting from the left, Cl, chlorine, Na, sodium, O, oxygen, O, oxygen. I've already done H. And the same thing on the right, you just mirror it. So you make a list, then you count how many. There's 2 hydrogen on the left, 1, 2, 1 chlorine on the left, 1 sodium on the left, and there's 1 oxygen on the left. On the right, there's 2 hydrogen, 1 chlorine, 1 sodium, and 1 oxygen. And if you look here, it's already balanced. They will trick you in the exam if they ask you something like this. Don't be alarmed. Double check your answers. And if you see that it's balanced, well, that's it. It's balanced. It's number one. Let's do number two. You've got hydrogen plus oxygen making H2O, which is water. Step one, make a list from left to right. There's hydrogen, there's oxygen. Same thing on the right. Let's count. There's 2 hydrogen, 2 oxygen. There's 2 hydrogen, 1 oxygen. Now we need to turn the oxygen, the 1 into a 2. We times it by 2. Put a 2, and that 2 goes out the front here. Why does it go out the front? Because if you add a 2 here, that's making atoms, which you can't do that. You can't make oxygen atoms, you can only rearrange atoms. Okay, this H2O is one compound. It's good to put brackets around it. Now the hydrogen becomes a 4, because you've got 2 times H2, 2 lots of 2. So to turn the 2 on the left into a 4, times it by 2, You get 4 and you put the 2, the thing that you multiply by, at the front. So now it's balanced. Let's do number 3. You've got sulfur plus oxygen to give you sulfur trioxide. Let's count. Let's make a list, I should say, first. SO, SO. Now we count. There's 8 sulfur on the left, 2 oxygen on the left, 1 sulfur on the right, 3 oxygen on the right. Let's fix up the sulfur first. Times that by 8 to get 8. Put an 8 here. There's now 24 oxygen. How do we turn the 2 into a 24 on the left? We times it by 12. We get 24 and put the 12 here. That's it. Let's do the next. This is a decomposition reaction of mercury oxide. Mercury is Hg and breaks down into mercury and oxygen. Let's make a list of the elements. And let's count. There's 1 mercury, 1 oxygen, 1 mercury, 2 oxygen. Let's fix the oxygen on the left by timesing by 2 to get 2. 2 goes out the front. Now there's 2 mercury on the left. We have to make 2 on the right by multiplying by 2 on the right to get a 2, and that 2 goes out the front. Let's do number 5. You've got zinc reacting with hydrochloric acid to give you zinc chloride and hydrogen gas. So let's make a list. And now let's count. 1, 1, 1, 1, 2, 2. Let's balance the hydrogens. On the left, times it by 2 to get 2. Put the 2 out here. And that fixes the chlorine problem. And now it's balanced. It's number 5. Let's do number 6. You've got sodium reacting with water to make sodium hydroxide and hydrogen gas. Let's make a list. 1, 2, 1, 1, 3, 1. Let's fix up the hydrogens. Let's times this by 2 to get 6 because 6 is common between 2 and 3 for the hydrogens on the left and right. So put the 2 out the front here, and I'll tell you why in a sec. Now there's 2 sodium, and now there's 2 oxygen. Let's turn this sodium on the left into a 2 by timesing by 2. Putting the 2 here. There's 6 hydrogen on the right. Let's turn that the hydrogen on the left into a 6 as well by timesing by 3. And the 3 goes out here. Apologies. Let me go back a step. There's now 4 hydrogen here. Because putting a 2 out the front here, you get 2 plus 2, that's 4. Let's turn this into a 4 by timesing by 2. Put the 2 out the front, and now the oxygen is 2 as well. So it's a bit fiddly. Number 7, decomposition of aluminium oxide to make aluminium and oxygen. Let's balance this. Let's make a list first. And let's count. Let's turn this into a 2 by timesing by 2. Put the 2 out the front. And let's find something common between these, which is 6. Let's put a 3 out the front here. Times it by 2 to get 6. Put the 2 out the front. Now there's 4 aluminium. Turn that into a 4 by timesing by 2 to get 4. And put a 4 there. And that fixes it. So that's how I do these questions.